Laplace transform of f of t by t. So division, we are doing division, so that's why we are writing t in the denominator. So f of t by t is equal to integral s to infinity f bar of s into ds, f bar of s into ds, right? Here f bar of s is nothing but what is that? L of f of t. F bar of s is nothing but f bar of s is nothing but L of f of t, right? So if you want to use the division by t property, so first we have to find L of f of t value. L of f of t is nothing but f bar of s value. Then you can apply the division by t property, right? Okay, so see here we have some note points. What that the first point is what that if the function is in the form of L of f of t by t form, by using the division by t property, what is the formula? Integral s to infinity f bar of s into ds, right? So like that L of f of t by t square, if in the denominator t square is there, means division by t square. If you have t square in the denominator, that is called division by t square property. If you have only one t in the denominator, we can write the single integration. If you have t square in the denominator, we can write double integral s to infinity f bar of s into ds, right? Similarly, if you have the t cubed in the denominator, that is called division by t cubed property, then what happen? What is the value of this one? We can write triple integral s to infinity f bar of s into ds, right? So like that you can write up to right now and so on. If you have t power 4, t power 5, t power 6, like that you can do it right now. So this is the division by t property, division by t square property, division by t cubed, right now. Like that division by t power 4, like that you can write it. Okay, so now we have to know the problems on division by t property. So what are the problems we have on division by t property? So one by one we have to see that. See the first problem on division by t property. Find the Laplace transform of of 1 minus e power t, 1 minus e power minus t, 1 minus e power minus t by t, right now. So this is the first problem. Find the Laplace transform of 1 minus e power minus t by t. So see here, what is the solution of this problem? See what is that? What do you want? We have to find Laplace transform of 1 minus e power minus t by t. So see here the function is in the form of L of f of t by t form. Okay, if the function is in the form of L of f of t by t, we have to use the division by t property. So to use the division by t property, so first we have to find L of f of t value, that is L of 1 minus e power minus t value, and then we can use the division by t property. So what we have to do first? We have to find L of 1 minus e power minus t value. First we have to find. So this is equal to what happen? L of 1 minus L of e power minus t. So this is equal to L of 1 value is 1 by s minus what is L of e power minus t value? This is in the form of L of e power minus at. What is that? 1 by s plus a. What is a value here? 1. right now. So this is equal to, it will be taken as f bar of s, f bar of s. Now by using, now what that, by using division by t property, by using division by t property, division by t property, we have what that, L of f of t by t, L of f of t by t is equal to integral s to infinity f bar of s into ds, right? Now what is f of t here? What do you want in the place of f of t? Can write 1 minus e power t. What happened? So therefore L of 1 minus e power minus t by t is equal to, what is that, integral s to infinity. What is f bar of s here? F bar of s value is 1 by s minus 1 by s plus 1 into what is there, ds. Now we can integrate this. So what is the integration of 1 by s? So the integration of 1 by x is, what is the integration of 1 by x into dx? The integration of 1 by x into dx is log x, right? So by using this formula, the integration of 1 by s is log s minus the integration of 1 by s plus 1. This is also in the form of 1 by x. So the integration of 1 by s plus 1 is log of s plus 1. Now the limits are, what are the limits here? The limits are s to infinity. Now the limits are s to infinity. Now we have to substitute the limits, right now. So see here, if you substitute the upper limit here in the place of s, what you can get, log infinity. Log infinity means it is a undefined value. So log infinity means what, that it is undefined value. So that's why if you have the limit infinity, we have to write s in the form of 1 by s form if possible, right? So see here, I can write this one as, if you substitute directly, what will get, undefined value you can get. That's why if possible, first we have to change s to the form of 1 by s, then we can apply the limits, right now. So see here, I can write this is equal to, this is in the form of log a minus log b. Now how can write log a minus log b? How can you write log a minus log b? Log a minus log b can be written as log of a by b. Now log of a by b, I can write this one as log of what is that, s by s plus 1, s by s plus 1. Now the limits are s to infinity. So this is equal to log of, so I will write in, okay, in the denominator s you can take the common, s is cancel. See here, I can write this one as s by, in the denominator I can take s common, then what will get, 1 plus 1 by s you can get, right now. What are the limits here? The limits are s to infinity. The limits are s to infinity. So this is equal to, here s is cancel, then you can get log of, what is that, log of, you can get 1 by 1 plus 1 by s, right? The limits are s to infinity. Now we can substitute the limits. Now we can substitute the limits here, right now. So substitute the limit in the place of s. What happen if you substitute the upper limit here? Log of 1 by 1 plus 1 by infinity. 1 by infinity value is 0. minus, substitute the lower limit s in the place of s. So log of, what is that, 1 by 1 plus 1 by s. So this is equal to, what is that, log of 1 minus log of, take the LCM here, what happen if you take the LCM, what is the LCM here, yes, then we can get s plus 1 by s plus 1 by s. So this is equal to log 1 value is 0 minus, what will get here, log of, what will get here, s by s plus 1. So this is equal to minus log of a by b can be written as log of b by a. So log of s plus 1 by s. So this is the solution of the first problem, right now, in division by t property. Now moving to the second problem. The second problem is find the Laplace transform of e power minus at minus e power minus bt by t, e power minus at minus e power minus bt by t, right? So what is the solution of this problem? See that, what do you want? We want Laplace transform of e power minus at minus e power minus bt by t. So what is the form of this one? This is in the form of L of f of t by t form. What is the form? L of f of t by t. L of f of t by t means we have to use a division by t property. Right now, to use the division by t property, first we have to find L of f of t value, means L of e power minus at minus e power minus bt value, first we have to find, right now, and then we can apply the division by t property. So first I can find what is that, L of e power minus at minus e power minus bt value. So this is equal to what happen, L of e power minus at minus L of e power minus bt. So this is equal to, what is L of e power minus at value? 1 by s plus a minus, what is L of e power minus bt? 1 by s plus b. Take this one as a bar of s. Take this one as a bar of s, right? Now what is that, what do you want? We need L of e power minus at minus e power minus bt by t value we need. For this we can use the division by t property. So by using division by t property, by using division by t property, we have what is that, L of f of t by t, L of f of t by t is equal to, what is that, integral s to infinity f bar of s into ds, f bar of s into ds. Right now, here in the place of 1 minute, right. See here, what is f of t here? E power minus at minus e power minus bt. So what happened here? Therefore L of e power minus at minus e power minus bt by t is equal to integral s to infinity. What is f bar of s value? 1 by s plus a minus 1 by s plus b into what is that? ds. So this is equal to, so this is in the form of integral 1 by x. What is the integration of 1 by x? Log x. Log x means here log of s plus a minus, this is also in the form of integral 1 by x. What is the integration of 1 by s plus b? Log of a s plus b. Now the limits are, what are the limits here? S to infinity. Right, here also if you substitute the upper limit infinity, you can get undefined value. So if possible, okay, you can write s in the form of 1 by s form, then apply the limits here. Right now, see here, what is the next step here? This is in the form of what is the form? Log a minus log b form. How can write log a minus log b? You can write a log of a by b. So means what happened? Log of s plus a by s plus b. Log of s plus a by s plus b. Right now, what are the limits here? The limits are s to infinity. Now this is equal to, see here, what is that? I can take s common in the numerator, s common in the denominator to get 1 by s form. What is that here? Log of, what happened? S common in the numerator, then what happened? 1 plus, okay, 1 plus a by s. In the denominator, s common, what will get? 1 plus b by s. Okay, the limits are, what are the limits here? Limits are s to infinity. Here s is cancelled. Now substitute the upper limit in the place of s. See here, if s tends to infinity, if s value tends to infinity, 1 by s tends to what happen? 0. Right now, substitute the upper limit infinity in the place of s, then what happen? Log of 1 plus 0 by 1 plus 0, because 1 by s value is means 1 by infinity value is 0, minus substitute the lower limit in the place of s. We can get log of, what is that? 1 plus a by s, and the denominator is 1 plus b by s. Right now, what is the next step here? So this is equal to, what is that? 1 plus 0 is 1. 1 plus 0 is 1. 1 by 1 is 1. So we can get log of 1 minus log of, take the LCM, then what you can get? S plus a by s by, what is that? S plus b by s. S is cancel, right? Then log 1 value is what is that here? 0, minus, here s is cancelled, then you can get a log of s plus a by s plus b, s plus a by s plus b. So this is equal to minus of log of a by b can be written as log of b by a, means log of what is that? S plus b by s plus a. So this is the solution of the second problem, right? Now see that, what is the third problem of the division by t property? So the third problem of division by t property is find the Laplace transform of find the Laplace transform of 2 power t plus cos 2t minus cos 3t by t plus t sin t, right now. So this is important problem. What is that? This is important problem for the examination point of view. This is very important problem, right now. See, what do you want in this problem? We have to find the Laplace transform of 2 power t plus cos 2t minus cos 3t by t plus t into sin t, right now. So we can write this one as what is that? L of e power 2 power L of 2 power t plus L of cos 2t minus cos 3t by t plus what is that? L of t into sin t. So we have applied Laplace transform to the individual functions. Take it as equation number 1. Now I can find each term separately. Finally I can substitute in the equation number 1. Now one by one I can find. Now what is that? Now first I can find what is that? L of 2 power t. L of 2 power t. See, we do not have the formula for L of 2 power t in the Laplace transform. So that's why I can write this one as in the form of exponential. So I can write this one as L of e power log of 2 power t we can write. Right here, what is the base? Base is e. This log is cancelled. Again you can get 2 power t. So this is equal to what happen? E power L of, right? L of, see, this is what happened here. This is in the form of log x power n. Log x power n can be written as n into log x means log 2. N into log x means t into log 2 here. So this is equal to, I can write this one as L of e power. So a into b can be written as b into a. I can write that one as log 2 into what is that? T I can write, right? So this is equal to, now it is in the form of Laplace transform of e power at form. What is the Laplace transform of e power at? 1 by s minus a. A means log 2. So what is the formula I have used here? L of e power at formula. What is L of e power at formula? 1 by s minus a. By using this formula I have written the Laplace transform of e power log 2 into t value, right? So the first part is completed, right now. Now going to the second part, take this one as what is that? Equation number 2. Take this one as equation number 2, right? What is the second part now? Now we have to find what is that? In the second part we have to find cos L of cos 2t minus cos 3t by t we have to find. By t, this is we have to find. So this is in the form of L of f of t by t. So L of f of t by t means we have to use a division by t property. So before going to use the division by t property, first we have to find L of f of t value. So here L of f of t means what is that? L of cos 2t minus cos 3t. So first we have to find L of cos 2t minus cos 3t value we have to find, right? This is equal to, so here the two functions are in the form of subtraction. Apply the Laplace transform to the individual functions. What happen? L of cos 2t minus L of cos 3t. L of cos 3t. So this is equal to L of cos 2t value is what that s by s square plus a square. A square means 2 square. 2 square value is 4 minus s by s square plus here a square value is what that 3 square. 3 square means 9. Take this one as a bar of s. Take this one as a bar of s. Right? Now what do you want? L of cos 2t minus cos 3t by t. So for this we have to use division by t property we have to use. So by using division by t property, 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 we have what is that? L of f of t by t. L of f of t by t is equal to integral s to infinity f bar of s into ds. So here what is f of t? F of t is what is that? Cos 2t minus cos 3t by what is that? T is equal to what happen? Integral s to infinity. What is f bar of s value here? F bar of s value is s by s square plus 4 minus s by s square plus 9 into what is that? ds. Right, now we have to integrate. What is that? Now we have to integrate. Now we have to what is that? Integrate. So how can you integrate that? Now we have to integrate this. How to integrate? See here. What is that? Here the derivative of s square plus 4 is what is that? 2s. Here we have the s. 2 is required. Here the derivative of s square plus 9 is what is that? 2s. Yes, we have yes. Right now we require what is that? 2. So just I can multiply and divide it by 2 here. What happened? 1 by 2 into integral s to infinity. What is that? 2s by s square plus 4. S square plus 4. Right now minus what is that? 2s by s square plus 9. Just I have multiplied and divided by 2. Right, now this is equal to 1 by 2 into, we know an integral formula. What is that? Integral f dash of x, integral f dash of x by f of x into dx. F of x into dx is equal to log mod f of x or log f of x. Right, log mod f of x or log f of x. By using that, see here what is f of s? This is in the form of f of x. This is f dash of x. The derivative of s square plus 4 we have in the numerator. Okay, 2s. The derivative of s square plus 9 is we have 2s. So it is in the form of f dash of x by f of x form. Right now, so the integration of f dash of x by f of x is log f of x. Now here log f of x means what is there here in the place of f of x? S square plus 4 is there. S square plus 4 minus log of what is that here? Log of, right? So the second term is also in the form of f dash of x by f of x form. So what happened here? Log of f of x. Log of f of x means here what is that? Log of s square plus 9. What are the limits here? S to infinity. Okay, here also if you substitute the upper limit infinity directly, what happen? You can get undefined term, right now. So that's why what we have to do, if possible you have to write s in the form of 1 by s, right now. For that see that this is equal to 1 by 2 into, this is in the form of log a minus log b. Log a minus log b can be written as log of a by b, means s square plus 4 by s square plus 9. The limits are s to infinity. So this is equal to 1 by 2 into, what is that? 1 by 2 into, see here, log of, we can take the s square common in the denominator and numerator. So s square I am taking the common, then what happen? 1 plus 4 by s square. So in the denominator also I am taking the common s square. What happen? 1 plus 9 by s square, right now. So this is equal to 1 by 2 into, what happened here? S square is cancelled. Substitute the upper limit infinity in the place of s. What happened here? 4 by infinity. 4 by infinity means 0. We can get what that? Log of 1 plus 0 by 1 plus, here what is that? 9 by infinity. 9 by infinity also what is that? 0. So anything by infinity is 0. Minus, substitute the lower limit in the place of s. What happened? Log of 1 plus 4 by s square by 1 plus 9 by s square, right now. Now simplify this one. What happens? See that? If you simplify this, 1 by 2 into log 1 value is 0 minus log of, take the LCM s square here in the numerator and denominator, then what happen? I can get s square plus 4 by, what happen? S square plus 9. S square is cancel in the numerator and denominator. So this is equal to, you can get 1 by 2 into minus log of a by b can be written as log of b by a, means what is that? Log of s square plus 9 by s square plus 4. S square plus 4. So this is the solution of the third problem, right? Now what is that? We have to know the solution of the fourth problem. So see here, take this one as equation number 3. Now the third part is what that? L of, now the third part is L of t into, what is that? Sin t. So this is we have to find. We can find this value by using multiplication by t power n property. If you want to use the multiplication by t power n property, first we have to find L of sin t value, we have to find, right now. So now first I can find L of sin t value. What is L of sin a t formula? A by, here a means 1. So 1 by s square plus a square. A square means 1 square. So this is equal to 1 by s square plus 1, right? So take this one as a f bar of s. Now by using multiplication by t power n property, we have what is that, L of t into sin t. L of t into sin t can be written as what is that, minus 1 whole power 1 into what is that, d by ds of f bar of s. F bar of s, because here n value is 1, so minus 1 whole power n. N means what that n value is? N value is here, n value is 1, right? So d by, what is the property we have used here? Since by using multiplication by t power n property, so this is equal to what happened here, minus 1 whole power 1 means minus d by ds of what is f bar of s value, 1 by s square plus 1. This is equal to minus, this is in the form of derivative of 1 by x. 1 by x derivative is minus 1 by x square. X square means s square plus 1 whole square, but it is not only in the form of s, so that's why again you can differentiate s square plus 1 with respect to s. So this is equal to, here minus minus is plus, 1 by s square plus 1 whole square into what is the derivative of s square plus 1, 2s. So this is equal to what is that, 2s by s square plus 1 whole square, right? So take this one as equation number 4. Now substituting, what is that, substituting the equations, substituting equations 2, 3 and 4 in equation 1. We get what is that, L of 2 power t plus what is that, cos 2t minus cos 3t by t plus what is that, t into sin t equal to what is L of 2 power t value, 1 by s minus log what is that, 2 plus what is L of cos 2t minus L of cos 2t minus cos 3t by t value, what is that, 1 by 2 into, from equation 3, what is that, 1 by 2 into log of s square plus 9 by s square plus 9 by s square plus 4 plus what is L of t into sin t value, from equation what is that, 4, from equation 4, what is L of t into sin t value, 2 by s by what is that, s square plus 1 whole square. So this is the solution of the what is that, third problem, right? So with this we completed the 3 problems right now in division by t. Now moving to the 4th problem. See what is the 4th problem here. The 4th problem is find the find the Laplace transform of e power minus t into sin t by t. Right, this is also very important problem, right? We have to practice this problem carefully right now. So what do you want? We have to find the solution now. Okay, find the Laplace transform of e power minus t into sin t by t. So right, so we can write this one as L of e power minus t into what is that, sin t by t we can write. Means first I can use division by t property. By using division by t property, first I can find L of sin t by t value, and finally I can apply the first shifting property, right? So see here, if you want to use the division by t property, first we have to find L of sin t value. So first I can find L of sin t value. L of sin t. What is L of sin t here? Listen to me. L of sin a t value is a by s square plus a square. Here a value is 1. So that's why I can write a means 1 by s square plus a square. A square means 1 square. So this is equal to 1 by s square plus 1. Right? So take this one as a bar of s. Now by using division by t property, by using division by t property, now by using division by t property we have what is that? L of f of t by t is equal to integral s to infinity f bar of s into ds, right? What is f of t here? F of t is sin t. So take f of t is equal to sin t. So what happened? Therefore L of sin t by t is equal to integral s to infinity. What is f bar of s value? 1 by s square plus 1 into ds. So this is equal to what happened? This is in the form of integral 1 by x square plus 1 into dx. What is the formula? Tan inverse of x. So by using that formula, what is the integration of 1 by s square plus 1? Tan inverse of s. Right? Now the limits are s to infinity. Now substitute the upper limit here. Tan inverse infinity minus tan inverse s. So this is equal to what happened? Tan inverse infinity means pi by 2 minus tan inverse s. Pi by 2 minus tan inverse s. So this can also be written as, what is that pi by 2 minus tan inverse s? So we know that, what is that? Tan inverse of x plus, right now, tan inverse of x plus cot inverse of x is equal to pi by 2. So by using this, tan inverse of x plus cot inverse of x is equal to pi by 2. So by using this, pi by 2 minus tan inverse of s can be written as cot inverse of s, right? So this is L of sin t by t value. But finally what do you want? We need what is that? Finally we want see, Finally, we want L of e power minus t sin t by t value we require L of, right now. So I can find that, please we want what is that finally. So see here, what is that finally we want L of e power minus t sin t by t we need. For that I can use first shifting property. So by using first shifting theorem or first shifting property, we have what is that, L of e power minus t into sin t by t is equal to what is that, L of sin t by t first you can write, then we can change s to what is that, s plus 1. Here what is that, a value is here a value is 1. Here in the exponential if you have the minus we can write here plus s plus 1. So this is equal to what is L of sin t by t value, cot inverse yes. So here we can change s to s plus 1. So this is equal to cot inverse of what is that, cot inverse of s plus 1, right. So these are the problems we have, what is that, we have under the division by t property. We have some more problems right now, you can work out them, okay. If you practice them carefully, right now you can get a better idea on division by t property. So what are the some of the problems we have in this division by t property? Please note down some of the problems. Fifth problem, what is the fifth problem here? Find the Laplace transform of first one under this. Find the Laplace transform of first one is cos at minus cos bt by t. Cos at minus cos bt by t. And second problem is sin t by t. So please practice these problems, right. Thank you.